Hello and welcome to this last problem which I will solve as part of this tutorial. I will make another episode, but this will only be a wrap-up. I will not solve another Euler problem in that one. This one is pretty funny. Problem 8. Find the greatest product of 5 consecutive digits in this 1000 digit number. And below it is a big block which contains only digits, and it's actually a very big number consisting of 1000 digits. The line breaks are there only for clarity. And so we gotta find the 5 consecutive digits which produce the greatest products, which means we take the first one times the second one times the third one times the fourth one times the fifth one, and we get the product. And we gotta find the 5 which create the greatest product, and this product will be the solution. Okay, let's head to the editor. Now, of course, I've left out the huge number from the comment this time, but I will insert it when it's time to do so. Namely now, I have it in my pasteboard, and trust me, this is the number. I will scroll to the right, it's 1000 digits long, scroll back to the left. We have the number declared as a string, as you can see, but what we need is a list of digits. And this time I'm really talking of a list and not a string. But I think to convert this long string into a list of digits is pretty simple. We can do this pretty fast. The main point here is to match 5 consecutive digits, find the product, and then check if it's greater than any of the other products that can follow. I will do a recursive method for that. I will call it greatest product, and what it receives as an argument is L, which is a list of int. And note that this time I actually wrote list. List in Java util would be an interface. In Scala it's not. In Scala, list is a very basic list type, which is basically the same as the Java linked list. And there are some pretty neat tricks we can do with lists. I will show you them. Of course, we want to return an integer. And that integer is the greatest product that we can find from the beginning of this list until the end. So, now, what we want to do is first extract the first 5 numbers from this list, find their product, and then make a recursive call with the same list, only without the first element. And we want to do so until we can't extract 5 elements from the list anymore, because we are close to the end of the list and maybe there are only 4 left. So, in order to extract something from a list, we can use a very powerful Scala operation which is called match. The whole thing is called pattern matching. And basically what you do is you have an operator which is called match, which is built into the Scala language, and we provide something that we want to match. In this case it's the list, L, and after that we simply write match. Now we have to open a block with curly brackets. And now comes something which is kinda similar to the Java switch statement. We can provide cases, but whereas in the Java switch statement you can only provide values for a case which are constants, in Scala it's quite different. Here you can define a pattern against which the value is matched, and this pattern can even contain variables, and those variables will be bound to the matched values in the body of the case. So let's say we want to match against the list, and now I introduce variables as elements of the list. There's no need to declare them as var or anything. If it's a lowercase name, then the compiler will see it as a new variable. So we got 5 values here, so I will simply write v1, v2, v3, v4, and v5. This would match a list with exactly 5 elements. Of course, our list will be longer than 5 elements, at least in the beginning, so this won't match. We gotta say we might allow something to follow after v5, but it doesn't interest us. And not only one element, but any number of elements. We say this by first using the underscore as a variable name, which in this case, in a match case, means this is a variable, but we are not interested in the value. It can be anything. It gets thrown away, but now this would match a list with exactly 6 elements, only that the 6th element will not be bound to any variable, which is not what we want. There's a special syntax for that. When you write an asterisk after the underscore, then the compiler understands that this underscore can be anything from nothing to a long list. So this would match a list with 5 elements or more. If the underscore asterisk, if a list would only have 5 elements and no more, then the underscore asterisk would match an empty list. And if there are more, it would match the rest of the list. But actually its value is thrown away. So, in order to provide the body of the case statement, we gotta write something like this. So now, what we want to do first is to create the product. V1 times V2 times V3 times V4 times V5. Now we have the product of the first 5 elements of the list. And what we want to do now is want to compare it with the greatest product of the rest of the list and find out which one is greater. So basically we will have 2 numbers in the end and want to return only the maximum of those 2 numbers. Scala provides an integer method which is very useful for that. It's called max. You need to give it another integer as parameter and it will return the maximum of the 2. So what we're going to provide, again we need to find the greatest product of the rest of the list. So if we would pass in L only here, we would match again in the recursion on the same list, which would be pretty bad because it would be an endless recursion. In Scala there's, or maybe when you come from Lisp or languages like this, then you know that every list has a head and a tail. The head is the first element and the tail is the list consisting of all the rest of the elements. And for example, a list that has only one element, there is a head and the tail is an empty list. So what we need here is the tail of the list. So we're going to recurse now and find the greatest product of the rest of the list, and the value of the match will be the value of this expression of the body of the case when it matches, when the match is successful. I like to, because this is a method which only has one parameter, I like to leave out the brackets and the period character here, as I explained to you in the first video. It's a question of taste. I like it better like this because max now looks more like an operator, and I feel it's an operator. I consider it an operator. However, this match now wouldn't be exhaustive. If the list were to contain less than 5 elements, it wouldn't match. So we need another case, because if it doesn't match at runtime, an exception is thrown, and at compile time you get a warning. There's also a catch-all case, like in Java. There's also in Scala. However, here in Scala you can simply match underscore, which matches everything, and the compiler will then recognize that this match is exhaustive with this case. In case we cannot match anything, we just gotta return 0 as greatest product. This completes our greatest product function. Now the rest is pretty simple. We want to print out something. We want to print out the greatest product. Now we got to pass in a list of integers. However, we only have a string. I showed you in the previous episode how to convert a string into a sequence. So we will do so again. We will say to the digit string to char array. Now we have an array which is a sequence, so we can call the map method and convert every single character to a digit. Now what we have is an array of ints, because an array when mapped returns another array. What we really want to have is a list. And it's pretty simple. There's a method called toList which converts it to a list. So now that should be it. I'm hoping that I did make no mistake. I'm going to compile this now. Waiting. Yeah, it compiled successfully. So let's run it. $40,824. I go back to the web page to verify the result. Scroll down. 40,824. The solution is correct. Let's get back to the editor. Now, this was really fast. I'm gonna make it in one video. I don't have to make a video break here in this episode. I think this was also very compact. I did not at all exhaustively explain the Scala pattern matching. You should look it up. It's much more powerful than this, and actually you can write your own extractors. An extractor is, for example, used here in the list case. This is the list extractor, and you can write your own. There is even an extractor which can match strings against regular expressions, and you can assign variables to the different matched groups, for example. Or you can make your own extractor which will recognize a date in a string and return it as a date object, for example. You can do everything you want here, almost everything you want actually. You can also, like list, make your own extractors that extract sequences which can be matched. And there's much more behind it. When combined with all of the other Scala features like mapping sequences or tuples, which I did not cover yet, you will find it very powerful, and actually much more powerful than the equivalent Java constructs. So I hope you enjoyed this so far. This is the last Project Euler problem which I will solve in this series, because the others are too complicated. The way to finding the solution is too complicated to explain it in such a short tutorial, and also it would be more of a Project Euler tutorial and less of a Scala tutorial. That's why I chose only these problems here for my tutorials. But nonetheless, I have given you now lots of hands-on examples which you can use to solve the other Project Euler problems on your own. Using Scala, I recommend you visit the site and just try it out. When you solved a few, you probably get a feeling of success, and you don't need to get yourself concerned with an IDE. You can just use a text editor. You don't need to invent an application architecture, because that's not what Project Euler is about, and you can make your first experiences with the programming language. So I'm gonna make another video which will be a short presentation about giving you hints where to go next, and I don't know, it's probably gonna take some time until I make it. Until then, have a nice time.